Good evening everyone. I welcome you all to today's lesson. So this is what we are doing today. So this is a past paper question that I want us to revise through. So in this question, the reason why I have brought out this question, I believe we are able to answer this one. If you are not able to get these 6 marks, which means that you just need to work on your calculator, but the knowledge you have, it is just the same knowledge. So even as we look at this table here, this is a grouped data. So we need to say this plus that, we are adding 10 plus 15, that's 25. 25 you divide by 2, that's 12.5. Just like that. That's what you are supposed to do. So the question is saying, the frequency table below shows the mark distribution for 30 learners in a mathematics test. This is the question. Then this is the data here. The first question is saying calculate the standard deviation. I believe we are able to calculate the standard deviation. Those of you that are facing challenges on how to calculate the standard deviation, make sure we revisit those videos that I was doing. The knowledge is just the same. So there's no need of answering this question because I explained this, I made some videos. So if you have forgotten how to answer grouped data, you can revisit. This is lesson 2. It was lesson 2. So this is very simple. So this is just one and the same. So I want you to answer this. I don't know if you will answer this. If I gave you to answer this question, I can't remember. But if I didn't give you to answer this question, we can go through this. We can answer this question. So if we didn't answer this, we can answer this question. We can answer this. So if you discover that from all the questions that I've been giving you, if we didn't answer this one, we can go through this question. We can answer the standard deviation. Or for the sake of practicing, we are learning. So I would advise we answer this. Or maybe if we didn't answer it, you can answer it. But if we answered it, no need of answering it. So my interest is not on this part. This part is very simple. I explained this. I labored so much on this. So those of you that are finding math error, you calculate to find the negative answer, you are just making simple mistakes, just one and the same. So revisit those videos that I made. They will really help you. So this is the question is saying, I'm interested in this part. So the question is saying, answer this part of the question on a sheet of graph paper. So for you to answer this question, you must have a graph paper, which I have. This is my graph paper. So you need to make sure that you've got your own graph paper. This is my graph paper. As you can see, I've got a graph paper here. So we need to make sure that we've got graph papers. Using the information in the table above, copy and complete the relative. We've made this word. Relative cumulative frequency. Have you seen this word, relative cumulative frequency? So even as you look at this table, it's different from the one that we've been doing. So whenever you've got these are what? These are rows. Whenever you've got 1, 2, 3, 3 rows, what you need to do is that you need to follow a procedure that I'm going to tell you. But when we're having 1, 2, and we are taught to complete those, as long as you're having 1, 2 rows, what we need to do is that we need to start with this one plus that one. You are going like this. Have you seen? But whenever you've got something like 3, this is relative cumulative frequency. This relative cumulative frequency is very simple compared to that one. What you need to do with this one is that you are taught to complete this. This is the first question. Copy and complete. So we want to find the values which are here. So how do we get to find those values? Have you seen? You get the last number here. Have you seen what's the number here? That is 30. So we'll be saying, so this 30 here, it is the one that you were using here. It is also called the what? Total frequency. If you add all this, if you add all these numbers here, you add all these numbers, you discover that you're going to get a 30, which is here. You're going to get that 30. And this same 30 is also given in the question here, 30 learners. Have you seen? So this is very simple. So you get 19, you divide by what? 30. This is what you're going to do. This you divide by 30, this you divide by 30, and that you divide by 30. Why are we dividing by 30? We are dividing by total frequency. So whenever you've got 1, 2, 3, 3 rows, you need to make sure that to find these values which are missing, you need to be dividing by the total frequency. You know the total frequency, summation of the total frequency. When calculating the standard deviation, the one that we use, this is the same one that we are going to use here. If you don't want to go that way, it is the number that is here, the last number here. Have you seen? So I say 19 divided by 30. What is the answer? So use your calculator. 19 divided by 30. The answer is what? This is my answer. I've pressed on my calculator. This is the answer I've gotten. Have you seen? 0.63333, just like that. So have you seen the answers are being given in what? 2 decimal places. This is 0.17, 0.27, 0.43. Have you seen? This is 0.07. So how are we going to write this? It was giving us 0.63333. So 2 decimal places. So the values which are here, it's 0.63. This is the answer. Have you seen? Then you go to the next one. So going to the next one, that's 25. You say 25 divided by 30. What do you get? We get what? This is our answer. Have you seen? 0.83333. So 0.83. So 0.83 like this. This is 28. 28 divide by 30. What do you get? Or we get 0.93. Have you seen? So this is how you need to work out this. So this one, I think it is very simple compared to the one that we did. I don't know if you are able to agree with me. This is very simple because just needs to divide. By that one, you are going zigzag. You start with this one, you start going like that. Have you seen? But this one is very simple and straightforward. So let's make sure we answer this, we understand this properly. So this is what we are going to do. So after we are done with this, how many marks? 1 mark. We are given a mark. Just to do that, we are given a mark. So now we proceed now. So where are we going to go now? So we go to this one now. So let's go to this other one now. Using a scale of 2 centimeters to represent 5 marks on the what? On the axis for this. Have you seen? We are given this. So this is what we are given. There is x here. So this is the x-axis. On the axis for what? 15 less or equal to x less or equal to what? 50. This is also something that we need to interpret. Have you seen? We are starting from where? You need to start from 15. So this is the data that you need to follow. On the x-axis, there is x here. You can be asking yourself, how did I know that this is the x-axis? In between these two numbers, there is x here. This is x. So this is the what? The x-axis. So even if they haven't indicated here, on the axis 4, this is the range that I'm given. And in between these two numbers, there is what? X. So they are telling you that in the x-axis, numbers should start from 15 to 50. Don't start from 0. So understand this, each and every question, like those questions that we were answering, the scale was starting from 0. It was very clear. Then you need to also understand this one. If it is starting from 0, you need to start from 0 to the given value. But this one is starting from 15 to what? To 50. This is what we are going. This is the what? X-axis. So you get your graph, like I told you. You get your what? You get your graph like this. This is your graph. Have you seen? So let me do this. Let me try to do this so that we can be able to see like this. Okay. So I'm going to do this. This is what I'm going to do. So this is your graph. So I told you that for you to answer these questions, you need to leave a line like this. Have you seen? So you need to put a line like this. You leave one box here. This is the first thing that you need to do. So you leave a box here, one box. Have you seen? This is your graph. This is your graph. You leave a box here. So a straight line like that. You leave a box here. You do this. Have you seen like this? Even down here, you leave a box. You leave a what? You leave a box. Even down here, you leave one box here like this. You do this. This is what you are going to do like this. You do this. Have you seen? So you say this is the what? X-axis. This is the x-axis. There, up there, we've got something like this. This is the what? The y-axis. Have you seen? So with this now, what I'm going to do next is that I check now. So I just read one part where it's saying 2 centimeters to represent 5. So starting from where? 15. So I'll be going in 5 is 5, 10, 15. Now I'm starting from 15. So 15, 20, 25, just like that. So this is just one and the same. So like this. So I'll start from here. This is 15. I need to start from 15. So 15, 20, 25, 30, 35, 40, 45, then finally 50. Have you seen? This is what I need to do. So this is the x-axis. And in the x-axis, they have put something here to represent 5 what? 5 marks. So in the x-axis, I've got marks here. So I'm going to put here, I've got what? Marks. This is what you're going to do. You put marks there. Have you seen? You put what? You put marks. Then you go on, you proceed saying, so we proceed, and a scale of 2 centimeters to represent 0.1 units on the y-axis for 0.0 y to 1. Have you seen? So the scale is starting from 0.0 to 1. Have you seen? 0.0 to 1. So the question is saying 2 centimeters. So what I'm going to tell you is that this scale doesn't change. As long as we've got 1, 2, 3, what you need to do is that this one is, you always start from 0 to 1. Whenever we've got 1, 2, 3. So this is just a leakage that I'm giving you. All the questions that have been coming in an exam, whenever we've got 1, 2, 3 like this, the y-axis doesn't change. What you need to do is that this is the y-axis. So here we've got 0.0. You are going this side. So here 0.0, here 0.1 like that. Here 0.2 until you reach 1. So you always be doing this as long as we've got 3 rows like that. Have you seen? As long as the table is like this, this is what you need to do in the what? Y-axis. So 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, then finally we've got a 1 there. Have you seen? Then you begin to do what? You begin to plot these numbers now. So I told you how to plot. So after you are done this, you put these numbers that you wrote now, you put them here like this. Nicely and properly like this. Have you seen? So you found what? They were just 3 like this. We add 0.63, 0.83, 0.93. You do this. Have you seen? This is what you need to do. So after you do this now, the other thing that we need to do is to plot this. So I'm going to show you how you are going to plot this. You need to forget about this middle row. You do what? You forget about this middle row. This one on top will be the x-axis. This one down is the y-axis. So you forget about this. Have you seen? So this is what you need to do. You forget about this. You concentrate on this one on top and this one down. So have you seen here? We've got this one. So this one is what? 15, what? 0.07. Have you seen? 15, what? 0.07. So this one on top is the x-axis. This one down is the y-axis. Then this middle row, you just forget about it because it just helped you to find these values here which you found there. So 15, 0.07. So this means that 15, where 15 is, you go to 0.0, then you count 7 small boxes. This is what it means. So you get your graph like this. You get your graph. 15 is here, 15 is here. Then 0.0 is also here. Then you count these small boxes, 7 of them. 7 small boxes. 1, 2, 3, 4, 5, 6, 7. This is where it is. Have you seen? You do this. That's where 15 is here. 0.0 is here. Then 7 small boxes like this. You move to the next one. So this is what you need to be doing. The reason why I've done this is that 15 is also here. But if 15 was here, I would have put the point here, then I count small boxes like that. But 15 is also starting here. So 15 is here, then 0.0 is also here. So I'll start from here, then count these small boxes, just like that. 7 of them. Then this is what? 20, comma what? 0.1. So you stand at 20. Then in the y-axis, you go where there is 0.1. Then you count 7 small boxes. This is 7. 1, 0.1. So the last number is telling you the number of boxes that you need to count. Have you seen? So you go 20, 0.1. Then you count 7 small boxes like this. So you get your graph like this. 20 is here. 0.1 is here. So around 20 here. You go around 20 here. 0.1 is here. Then I count 7 small boxes. 1, 2, 3, 4, 5, 6, 7 here. This is where the point is. Have you seen? So I put the point. So I've got 1, 2. I proceed. I go to what? 25. 25, what? 0.2. Then 7 boxes. Have you seen? 25. 25. Where is 25? 25 is here. Then I've got what? 0.2 here. Then 7 boxes. Along this 7. 0.2 here. 1, 2, 3, 4, 5, 6, 7 here. This is where the point is. So I've plotted 3 points so far. So we are able to see how they are moving. This is what we need to do. I move to 30. So I move to 30. 30 here. Then comma 0.43. For what? 43. This is what we are going to do. 30, 0.43. So 30, where's my 30? My 30 is here. 0.4, it is here. Then 3 boxes. So around 30 here, you check in the y-axis 0.4. Then 3 boxes. 1, 2, 3. There. That's where the point is. You do that. You check. You go to what? 35. So 35, 0.63. So 35 is here. 35 is here. You check now. 35, you start going 0.6. 0.6 is here. There. Have you seen 0.6? So it is where? Here. Then I'll count 3 boxes. 1, 2, 3. Like this. This is where the point is. Have you seen? I go to what? I move to 40. 40, what is 0.83. 0.8. 40. Where's my 40? Where's my 40? My 40 is here. Then 0.83. 40. I go. 8 is here. 0.8 is here on this line. Then I count 3 small boxes. 1, 2, 3. Have you seen? So the last number is telling you the number of boxes that you need to count. Then after you do this, we go to what? 45. 45, what? 0.9 what? 3. 45 is here. 45 is here. 0.9 3. So 45 is here. It is 45. I move. 9 is here. As you can see, 9 is there on this. So then I count 3. 1, 2, 3 here. This is where the point is. Have you seen? Hope we are able to understand this. Then finally, the last one is 50, 1. So 50 is here. You move around this until you meet 1. 1 is here. So it is here like this. Then you just join them. Have you seen? So I'll just join them like this, starting from here. So I'll just join them like this. I just join. I join them. I join them like this. Have you seen the way my graph is? I've joined them. So this is what we need to do. Have you seen this? This is how your graph is supposed to be. So with this now, so I've answered. So far I've got 4 marks. Plotting this is 3 marks. Then answering this, it's 1 mark. So I go to my question. What is my question saying? I go to my question. Showing your method clearly, use your graph to estimate the semi-interquartile range. What? Semi-interquartile range. So the first thing that you need to know is the formula. How is the formula? Semi-interquartile range is equal to half like this. Then you say Q3 minus Q1. Have you seen? So upper quartile minus the first quartile. This is the formula that we need to be using. So this is the formula. So I told you that, okay, let's find first quartile 3. So you know this formula on a separate paper. So the same way I've answered this is the same way you're supposed to answer this. Quartile 3 is equal to, I told you you're supposed to do 3 over 4 times the number, highest number in the y-axis. So you check y-axis, highest point here. It's what? 1. So you multiply by what? You multiply by 1 is equal to what? So you get your calculator first. You get your calculator. You say 3 divided by 4. What is your answer? 3 divided by 4, that's the answer. Then the same answer multiplied by 1. It's what? Same 0.75. So you go, it is what? 0.75. I repeat, this is not your answer. So this is not your answer. Make sure you get this. This is not your answer. This is showing you where the answer is. So you go on your graph where there is 0.75. So this means that you go where there is 0.75. So on your graph, 0.7 is here. Have you seen? 0.7 is here. Then I count how many small boxes? 5, because I want to find 0.75. So 5, 1, 2, 3, 4, 5. It is here. Then I put a what? I put a line. The same way I was doing. So the same way we were doing. So I believe we are able to do this. So you do this here. You do this. This is what you're going to do. A line like this. A straight line like this. Touching the cave. The moment this one touches the cave like this, then a line comes down like that. Have you seen? So this is now my answer that I'm going to get. So I do this. So straight from there. Straight like this. You like this, a dotted line like this. This is how your graph is supposed to be, everyone. So you need to have a neat graph. You're even jealous of your graph. Even as you are submitting, you're even jealous that the sir will be very impressed by this. Have you seen like this? So it is cutting here. You say, okay, this is 35, this is 40. Have you seen? So which means here I've got 10 boxes. So you can even use some logics here. 10 boxes, which means 2 is 1. Have you seen? So you say this is 36. 2 boxes, it's 36. We've got 10 boxes. So okay, 10. Then here the difference is 5. So just 10 divided by 2. Have you seen? You are going to get a 5 there. So which means it's 2 boxes, 5. 2 boxes, 1. So 1, 2, 6, 7, 37, 38. So 38 is your answer here. 38 is your answer. So you check. So you say Q3 is equal to what? 38. Have you seen? Q3 is equal to what? 38. So Q3 is equal to 38. You go to what? Q1. So have you seen? This is not your answer. The answer is the one we've plotted here, which is 38, is the one that you are going to get. So you go to what? Q1, which is equal to 1 over 4 times highest number is 1, is equal to what? You get your calculator like this. You get your calculator. You say 1 divided by 4. Have you seen? It's equal to that. Then times 1. It's what? Same answer. What's the answer? 0.25. So I go where 0.2. This is not my answer. I repeat, please. This is not your answer. This is telling you where your answer will be found. So you go to 0.25. So 0.25, 0.2 is here. Then 5 boxes. 1, 2, 3, 4, 5. It's here. Have you seen? Then you put a ruler. You get your ruler like this. This is what you're going to do. You do this. A straight like this, straight line like this, you do this. So this is what you are going to do. So you do this, then this is, you put a line like this. Have you seen, you put a line like this? So this is Q1 that you're finding is equal to, you check now, this is coming down like this. So this is supposed to be a dotted line like this, a dotted line like this. So it is cutting where? Where is it cutting? It is cutting here. This is where it's cutting. This is 19. Okay, this is 20. Here that is what? 25. So this is 24. Have you seen? I can tell this is 24. So I put 24 here. Since I've got the first quartile and the third quartile, then I can therefore conclude now. On here, on a separate paper, the question was on what? You check, this was 3. So nicely you indicate here. So even as I'm marking, I'm even jealous of your graph. You say semi interquartile range is equal to half, then you say Q3 minus Q1. You do this, which is equal to half multiplied by Q3 was what? 38 minus 24 Q1, like this. Half is equal to, you say 38 minus 24. 38 minus 24. 38 minus 24. What do you get? You get 14. It's 14 there. Half of 14. So this half, this is, you multiply 1 over 2 times 14. You're going to get 7. So this is your answer. 7 is your what? 7 now. 7 what? In the x-axis we add the marks. So it's 7 what? 7 marks. So even here, in the x-axis here, I told you we add what? Marks. So you can put marks. So you can say here we've got what? Marks. Like this, you put marks. So even there, just to make sure that your graph is neat like this, you put what? You put marks. So this is your answer. Then you know how to find the interquartile range. You just remove the half here. So the interquartile range here is what? 14. But the question was find the what? Semi interquartile range. So we multiply by half. That's why we got